There's a lot of you in this class that don't cooperate with me a lot. It's starting to eat away at me. Because I'm not going to go the rest of the year where I got to beg people to cooperate. And I get the same 2 or 3 people raising their hands. I mean, sometimes I think I'm the only one in the room up here. And there's invisible people sitting in the chairs. Everyone, get connected here. Is that a pass there, Jack? Just put it on my desk. Quinn, you connected there?
Yeah, I'm on it.
It's not coming up here yet. Jack, hurry up. Go to eBackpack. Thank you. Do you know who that's from?
Miss Priest.
Okay. Oh, I know who it is. Thank you. All right, tap on properties of logarithms answer sheets. Now, listen to me, fellas. If you're not going to use these answer sheets the proper way, I won't do it anymore. And the reason why I'm saying this is that quiz you just took yesterday. You know, 1 or 2 days before the quiz, it was all those exponential equations and those log equations where you had to convert. I graded some papers, I don't remember who. I graded some papers. The second part of the quiz, you know, you had to convert it to exponential form first and then go from there. I had some papers, didn't even do that. You just said x equals, and you wrote a number down. I don't know where you got it from. And the other ones, the first 10, you had to get a common base. You got to show me what you're doing. That wasn't a good set of quiz grades. And again, thank God that was just a 20-point quiz. The stuff that was on that quiz, you'll get the papers back tomorrow. I still have a few people. It ain't going away. It ain't going away. What I mean is the stuff that was on that quiz is still going to be coming up and stuff that you need to know for the 4th quarter. So when I give you that back, you better take a hard look at that. Now, look at, you want to take a quick check here? Here's those 2 assignments you did on properties. The first one was page 685, 5 to 15. That's where you had to keep breaking it down, breaking it down, breaking it down. And then the second assignment was 19 to 30. Those were the ones where you actually kind of went backwards, right? Till you got a single one. Now, it looked like you all did fine on that from what I saw. But there's the answers. If you don't necessarily get a chance to check it all right now, they're there. Do it. Some of you don't do it. And you're making mistakes, and then you take the quiz or the test, and you get them all wrong again. That's why I put those on there. You got to look at this stuff. The properties that were here, that ain't going away either. You still got to know how to do that. Then you want to have a question on those? I mean, it looked like you all did fine on this assignment. But that quiz wasn't so good for some of you. Yes?
For 27 and 28, do you need the parentheses?
Yes.
What is
Swipe to the second, or wait a minute. No, it'd be the 3rd page. See 27, it was the log of x plus 3 times x minus 3, so that's the log of... Are you saying, do I need the parentheses around the x squared minus 9?
Yeah.
Yes. Because if they weren't there, that log would technically only be on the x squared then, when it's on both of them. That's why you need the parentheses. All right? everything here. Your grade in the third quarter is done. I didn't go through them yet, but that quiz finished off great. All right. Go to a brand new page in your notebook. Brand new page. This is Tuesday, March 28th. You need your calculator out. We're gonna be doing something with this. All I'm gonna do today is show you how to use the calculator with logarithms. And then tomorrow, the rest of the week is gonna be problems where you gotta use what I'm about to show you.
These need to be in degrees or radians?
Huh?
These need to be in degree or radians?
What this is logarithms. This has nothing to do with degrees or radians, so that doesn't matter. Okay, this is what I'm gonna show you today. There's two kinds of logarithms you can have, common logarithms or natural logarithms. Now, I'm just gonna explain to you what both of them mean and how to use the calculator to find them. Okay, now you need to write that down, everybody. Logarithms to the base 10 are called common logarithms. Just mark that down, and then I'm going to show you how to write it. Logarithms to the base 10, and this is another thing. And this is another thing. Some of you, when I tell you to mark things down, some of you aren't even marking anything down. I mean, how in the hell are you going to understand what's going on? And then sometimes a kid comes in the next day, well, I don't know how to do anything. And then I look at the notebook and I see nothing there. Well, I don't have any sympathy for you then. You gotta mark the stuff down. Logarithms to the base 10 are common logarithms. And here is how you write a common logarithm. So in the blank there, this is what you're gonna put, where it says, and is abbreviated like this. Okay, now, you probably should have a question for me right now. What I mean is, some of you are probably wondering, well, what's the base? When it's written like this, it's assumed it's a common logarithm, and that's just the word they use for it. So what I'm saying to you is, if you see something like this and you don't see a base, it's a 10. It's assumed to be a 10. But when you look at it in a textbook or anything, you're not going to see anything there. So what I mean to say to you here is, this means that. So when you don't see a base there, it's a common logarithm, which means base 10 all the time. Okay, now watch this. Now have your calculators there. Now this part will be easy. Now I'm just going to make these up. Just in your notebook, put them one in a column the way I'm doing here. Okay. Now, you all got your calculators there. Now, you guys that got the fancy calculators, you know, you're probably going to have to hit the LOG button right away. If you got just a regular calculator, see, I just have a regular scientific calculator. I got to put the number in first and then hit the LOG button. Now, find that button on your calculator. It's there. It should be marked LOG for logarithms. No surprise, right? So locate that on your calculator. Now, look at what I just clicked up here. When you have to find the logarithm of anything, you're going to give the approximation to 4 decimal places. Now, do you notice? No base there. So it means it's a 10. It's a common logarithm. Now, this part's going to be easy. Punch in your calculator. What's the log of 327.1? Now, gentlemen, look, this should make sense to you. When I first taught you the word logarithm, what was the one thing I kept repeating all the time? What is a logarithm? I mean, come on, that first day I started all this, I kept saying it, I kept repeating it over and over again. A logarithm represents a what? An exponent. So, look at this. Now, you don't see it there, but it's a 10, right? So, isn't the answer to this 10 raised to what would give 327.1, right? Just like before. Now, your calculator is going to figure that out. Now, make sure you all do this, because you all got different calculators. What is the log of 327.1 to 4 decimal places? Just punch it in. And somebody just raise your hand and give it to me. 4 decimal places. Max.
I got 2.5147.
2.5147. Now, listen to me. All I'm doing today is showing you how to use the calculator. Tomorrow and Thursday, I'm going to get into actual problems you have to solve, or you're going to be using the calculator. Okay, what's the answer to the next one? Somebody? Log of 437,000. What do you got? Let's punch it in. Howard.
5.6405.
Now, I want you to watch what's going to happen here. Go ahead. First, let me hear the answer. What's the log of 0.0615? Andrew.
Negative 1.2111.
Now watch this. Watch this. See this right here? Notice the answer was negative. What if I said convert that to exponential form? You guys already know how to do this, and you can't forget how to do this, because it ain't going away. Convert that to exponential form. See, what's the matter, you guys? This is what I'm talking about here. You can't forget this stuff. Now, all you that are just sitting there really don't know how to convert to exponential form, I find that hard to believe. Rob.
10 to the negative 1.2111 equals 0.0615.
Right? 10 to this equals this. Now look what I'm going to click up on the board here. You don't have to write that down. Just look what it says. The common logarithm of a number between 0 and 1 is always going to be negative. Isn't that between 0 and 1? Yeah. Anytime you take the common log of a number, it's always going to be negative if it's between 0 and 1, because the logarithm is the exponent on 10 that produces the number. The logarithm is the exponent on 10 that produces the number. This would have to be a negative number, because doesn't this mean 1 over 10 raised to that? You know, if you moved it down? So bottom line is, whenever this number is between 0 and 1, the answer is always going to be negative. Now look at this one. Now, what the hell's that called? I know you do that in science, right? I would think. You see how I wrote that next number? What is that? How did I write it? I can't believe you don't know this, because I know this stuff comes up in science. Nick?
Scientific notation.
Scientific notation, right? What does that mean, somebody? See, I'm assuming you know how to do this. assuming too much? What does that mean, 3.73 times 10 to the fifth? What's that mean, Chris?
Move the decimal place to the right 5 times.
Move the decimal point to the right. So actually, what is that number? That's just a regular number. What is 3.73 times 10 to the fifth? That's just one number. What is the number? Dave?
373,000.
Okay, now, you've got two ways to do this. Now, I want you to find on your calculator, you should have a button that's 10 to the x. I would think. I want you to locate that. Now, it might be a second function key. You know how if it's up above, you gotta hit that second function key, right? All right, you all see a 10 to the x key there? Now, you could get the answer to this two ways. If I wanted you to do 10 to the fifth on your calculator, where you have that 10 to the x, now for me, I'm just gonna enter 5, and then I'm gonna go second function key, 10 to the x, and it comes up 100,000. So if you wanna do this using that key, you would just, no, your fancy calculator, you gotta hit this first. You would go 3.73 times, and then enter 10 to the fifth, which is this. Well, either way you do that, somebody, give me the approximation for that. What's the answer to that? I don't care if you change it to this first, or you actually punch in 3.73 times 10 to the fifth and use that key. What's that answer? Make sure you do it, everybody, because the next 2 days, if you don't know how to use the calculator, you're screwed. You ain't gonna be able to do anything. John?
5.5717.
5.5717. All right, that was pretty easy, wouldn't you say? Just finding a common logarithm. Now, on your iPad, okay, I'm directing you to go to your textbook right now. Should be automatically going to that class schedule app. Okay? I want you to go to page 688 in your textbook. We got one more thing to do here. Go to page 688. Okay. You don't have to write down what I just clicked up there, but everybody get to page 688. Are you there? Look at the bottom of page 688 where it says objective 3. Look at the bottom. Now, look what I wrote up here. The most important logarithms used in applications are natural logarithms, which have as base the number lowercase e. Now look, this is the first time you're hearing this. Let me explain what I mean by that number. Look in your book at the bottom of page 688. The most important logarithms, again, which have the base e. The number e, now here's what it looks like. It's just a lowercase small e. The number e is a fundamental number in our universe. Now I'm reading right out of your book. For this reason, e, like pi, is called the universal constant. The letter e is used, oh, and it just gives the guy's name there, who invented this a million years ago. Look at the last sentence at the bottom of page 688. Since it is an irrational number, its decimal expansion never terminates and never repeats. Now, on your calculator, everybody, there should be a button that says e to the x. Locate it. On your calculator, look, there should be a button labeled like this, small e to the x. Now, here's the first thing I want you to do. I want you to determine for me, what's the decimal approximation for just e. So if x is 1, that's just e to the first, right? Which is e. Now, using your calculator, you see the button e to the x? You know, you're going to put in 1 for the x, and I would like one of you just to raise your hand and tell me what decimal approximation is it giving you for e to the first. That's all I'm asking. Just start giving me the decimal approximation. Now you guys got to all do it because you got to make sure you're doing this correctly. Andrew. 2.7183. 2.718. Okay, 3 if you go to 4 places. Now, and it keeps going, right? On your calculator, it probably keep going. Now that's the decimal approximation for this number. Now, somebody, or everybody, punch in e squared. Go ahead. Punch in e squared. You got to make sure you're doing your key functions correctly. Tell me what it says for e squared. Chris.
7.3891.
If you're not getting these numbers, you got to make sure you're getting these numbers. Somebody, give me the decimal approximation for e cubed. Just doing a little exercise here to make sure you're getting the right answers. Rob?
20.0856 or 55.
Okay. What about e to the 0.6? Somebody go ahead and punch in e raised to the 0.6 power. What's it say? Howard?
1.8221.
So that's powers of e. Now, watch this. All right, you don't have to write that down. Look what that, the number e is an irrational number. Its decimal expansion never terminates and never repeats. You know pi? I don't know if you saw that, you know, they did that pi thing on Pi Day. You know, who can know the most digits of pi? But you realize that goes 3.1416, and it goes like in the millions. It just keeps going, right? Same with this number. This is just another constant in mathematics. Now, this stuff with logarithms, you're going to see it next year across the hall when you take calc honors. That's why we're doing this a little bit now. It's going to come up again in calculus. That's why we do it the year before. Joe?
How do people find that stuff?
Pardon me?
How do people find like I and E? Where do they?
I give up, Joe.
There's
The mathematical geniuses from a million years ago. That's how I'm going to answer that. Good way to answer it, right? Okay? We're just using what's been published over the years, okay? So accept it as the truth, all right? Now, you always have questions like that. Okay, use your calculator to find powers of e. We just did that. Now, what does that say? Okay, you see the second bullet? The base e logarithm of x. You got to write this one down. This is important. Second bullet. It says the base e logarithm of x is written, and put a blank. The base e logarithm of x. See that? Second bullet there. The base e logarithm of x is written. Now watch this. There's how you write it. ln of x. Now guys, on your calculator, locate the natural logarithm key. It's there. It says ln of x. All right? I'm sure you see it there. Okay. Write these down. I'm almost done. And you're gonna do these in class. This is all calculator stuff. attention. What's the matter?
Would it be like LN on a calculator?
Yeah, that's what I said.
Oh, LN? Oh,
That's what this is. Ln of x.
I was like, I thought it was M.
It's cursive.
No, L. Holy crap. All right, how's that? That's an M. Thank you. It's Ln of x, but that's what I said. And that's on your calculator. Now, notice, there's no base there. What's that mean for a natural logarithm? Oh my God, I've already said this when I gave the initial definition. Common logarithms, log of x, always have a base of 10. Natural logarithms, what's the base? They ain't going to write it. It's understood. David, that's right. You understand? Look. When you see ln, the base is e. They ain't going to write it. But it's there. Just like log of x, the base is 10. Now, if a math problem is any other base, you'll see the number written there. Okay? So with your calculator, same as before, somebody give me the 4-digit approximation for the natural logarithm of 0.5841. Now you're going to do the same as before, but you're hitting a different key. Somebody. Punch it in. Make sure you're doing this, fellas. You're going to be lost the rest of the week if you don't know how to use a calculator. Ethan.
Negative 0.537. Yeah, 77.
Why is it a negative answer? Were you paying attention earlier in class? Because that's true for natural logarithms too. Why was the answer negative? Adam.
Because it's between 0 and 1.
Because this number is between 0 and 1. Whenever the number is between 0 and 1, it'll always be a negative answer. All right, what's the natural logarithm of 192.7? Rob?
5.2611.
What's the natural logarithm of 10.84? These are just random examples. What's the natural logarithm of 10.84? Somebody else here, please. Come on. Max?
2.3832.
Now, listen to what I'm going to ask you here. You see the key that says e to the x. I want somebody first. I want you to use your calculator and give me that number. And we already did this, you know, e to the first, e to the second, e cubed. So you're going to have to use the e to the x key. So put it in there when it's a 3, but multiply it by 5.71. I want somebody to give me what that number is of 5.71 times e cubed. What is that number? Jack? Now, when you enter your calculator, you can enter right in there, 5.71 times e to the third, and then take the natural logarithm of that. What's the answer? What's the answer? Tim? Well, your hand wasn't up? Put your hand up. Okay, I must be seeing things. Somebody? Ethan? 4.7422. Now, do you see what I did here? Do you have to necessarily write that for me? No. You can just enter 5.71 times e to the third right in your calculator and hit ln, and you can go right to that. Yes. Yes. Does anyone have a question? All I did today is show you how to find common logarithms and natural logarithms using the calculator. That's all I did. Now go to page 691 in your textbook. Now take out a good sheet